Hi Akshay, how are you? Am I audible, Akshay?
Yes, sir. You are audible.
Okay, great. How are you?
I'm fine, sir.
Fine. Okay. You are able to follow the lectures, right?
Yes, sir.
Okay, great. We'll wait for some more time. Okay. See if let's see if others are joining. Okay. We'll get started.
Okay,
You
sir.
have Aspen with you, right?
So,
Huh?
yes, sir.
We
Sir,
can do
I did
some.
one.
Hmm?
Sir, I did one mistake during registration of exam.
Okay.
I did payment, but my response was not recorded. So,
Uh-huh.
what I do?
Can you mail to professor? Because I don't know what should be done.
No, sir.
Just send a mail to Professor Prabhikar Kumar Saha.
Okay, sir.
Okay.
I will do.
Yeah, because I don't know what should be done in this case. So,
Okay, sir.
you have Aspen right
I
today?
check. Yes, sir. Yes.
Okay, great. Just keep it ready. Yeah,
Yes, sir.
you were telling something.
Yes, sir.
What errors, Akshay? You can just unmute and talk. What errors, Akshay? Just unmute and talk. You don't have to put everything. I'm just waiting a few minutes, okay? Hoping that others will be joining. We'll get started soon. So, meanwhile, you can keep your Aspen ready. So while solving last week problem, you had issue with uh, where we were solving the LNG operation, right? You had some error with that. Just unmute and talk, either Akshay or Harshit.
Hello, sir.
Yeah, Akshay, tell.
Sir, during the lecture, I did a, simulation, hydrodealkylation of toluene. So after completing my flow sheet and all the input requirement, I got the error. The following convergence blocks were completely with errors.
Okay, so Acha, okay, you are asking with respect to the lecture, not with respect to the tutorial thing, right?
Yes,
Okay, okay. Which
yes,
process
sir.
you're talking about?
Uh, hydrodealkylation of toluene.
Hydrodealkylation of toluene. Okay. Okay, let me check it, Akshay. I'll get back to you. I need to do the simulation study. I'll do it and get back to you, okay?
Yes, sir. Thank you,
Okay,
sir.
okay. Shall we get started? I don't think others will be joining. We are only three today. So maybe since both of you have, Harshit, you also have Aspen, right? So we'll do one thing. We'll just directly start with some simple flow sheet. Okay, today I'll just share my screen. Let me just confirm that it's getting recorded. This is getting recorded. No, we are not solving the last week question. No, last week we have simulated. We said we'll be doing optimization study. We'll shift the optimization study to the last class. Okay, we'll do some more flow sheets today. Okay. Once we are good with the flow sheeting simulations, then we can go ahead with the optimization. So this is a simple flow sheet which has been shown. So there's a feed which is at 1000 Fahrenheit and 550 psi. Okay, it's a mixture of hydrogen, methane, benzene and toluene. We have a cooler which brings the temperature down to, then we have two phase separators. Okay, so that's all. We have only 4 unit operations in this case, and the information required for simulating this process is already given. Okay, so can you start setting up this flow sheet and just tell me the answers which you get after the simulation. You can see the question, right? Any confirmation that you are able to see the question? Yes, great. Thanks, Harshit. Okay, it's a simple question. Okay, it's not at all complicated. We'll do some interesting questions today. Okay, so I just started with a simple question. Then later on, we'll do an exercise on liquid extraction process, and then one question on ammonia production if time permits. Okay. So I will also do things parallelly. Once after showing you the question, I'll wait for some time. I'll also do. Okay. So today, only both of you are present. Okay, so we can discuss a lot if you have any questions. So feel free to ask. In case if I'm unable to answer your question at this point of time, I'll try answering in the next class. Okay. Can you tell me your status? Where are you? Done? Finished? Great. Akshay, what about you? Just see, Harshad, if you have done some mistake. Akshay, you also completed. Great. Okay, let me also just do it. We'll compare our results, okay? Because I didn't, just give me just a couple of minutes. Which property method is bank graphics, right? Let me go to simulation. So all I have is 3 unit operations, right? One is this, another one is 2 fast phase separators, right? That's all right I have, or do I have anything else? Nothing. So it's going here, it's going here, it says here, it says it's going here. That's all. So the feed stream is 1000 Fahrenheit. 1000 Fahrenheit, 550 psi. Right, it says hydrogen is 405. It's which units? LB mole per hour. Okay, LB mole per hour. Hydrogen 405, methane 95, benzene 95, toluene 5. Done. Next, it says pressure drop to 0 and outlet is 200 Fahrenheit. Just make sure that you give appropriate units. Sometimes it troubles a lot. Is the second phase separator. It says outlet is 1 atmospheres and heat duty is 0. Oh, I think I gave wrong value. Okay. This is the one. It says this is 100 Fahrenheit. 100 Fahrenheit and pressure is 500 psi. Right, it's given. Let's go to 4. Heat duty is 0 and pressure is 1 atmospheres. Great, that is satisfied. Yeah, so what question says as what is the heat duty of cooler block, right? So it says, let me put it in kilo. It says 2109 kilowatt. Is that what you got, both of you? Can you put your answers in the chat box? Oh, okay, Mr. Arun, this is the problem statement. Okay, you can take the screenshot of it. It's a simple problem. You have only 3 unit operations. Maybe from second question you can join with us. Both Akshay and Hashit, can you just put your answers, whatever you got? Okay, yeah, that's what I too got. Great. And the second question is heat duty of the first phase separator, right? So let us see. So heat duty in kilowatt is 272.8. Is this what you got? Okay, great. And the third question is temperature of FL2. It's straightforward, right? I think for this one we don't have to do any simulation because T4 and T5 will be the same, right? So it's 37 degrees centigrade, right? Fine. Or if we put it in Fahrenheit, it will be 100, close to 100. Fine. Okay, so let's go to the next question. Okay, so we have a process where we want to extract acetone from water. Okay, that's our aim. We are using MIBK for that. So in this case we are using two decanters in series for separation. It's like a two-stage separation. Okay, so I want you to just start the extraction process simulation. First initially just give the components. Okay, we are interested in using acetone, water and MIBK. Okay, methyl isobutyl ketone. Okay, so the flow sheet is given over here. Yes, so the required input data is also given. So the question is clear, right? Does it require any explanation or is it self-explanatory? I want you people to simulate only this part. Okay, just add a mixture and a decanter, leave the rest. Okay, just tell me once you have simulated this section, the first mixture and the first decanter. Okay, don't set the entire flow sheet, just tell me once you have simulated the mixture and the decant one. Okay, just two of them, because I'll also do parallelly. And initially use ideal equation of state for calculations. I have few questions. Okay, the question is ensure that you have chosen ideal property method, run the simulation and tell me what do you observe with respect to separation and give me the explanations for results obtained using ideal equation of state for first decanter itself. Okay, don't worry about the rest, simulate only this section of the process. MIBK is methyl isobutyl ketone. It's here, see? I'm just showing you, I'm pointing it out. Methyl isobutyl ketone. Okay. Just only simulate the first section, the first mixer and the decanter. Okay, just put a message once you have completed simulating these two unit operations, and use ideal equation of state. Don't worry about the warnings. One of the question which is asked for you is, explain why you are getting some warnings. Okay, so I want you to interpret the results. Simulating Aspen is like click 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 business, but it's important to interpret the results which you get from Aspen. Okay, so for the first idea is to use the ideal equation of state and try interpreting results and then change the equation of state. Okay, so initially use ideal and give me explain why you are getting warnings and all. Okay. Can you just update me? Where are you now? Which block you are simulating? decanter conditions will be same as the inlet conditions. Okay. Yes, it's the same as the inlet conditions. Since let me also open and look at. If my PK comes directly from Pascal. Decanter conditions are the same as the feed conditions. Okay. Yes, 75 and 50, correct. What do you think? Which one is the key component? See, I intentionally didn't give some of the information. Okay, I want you people to think what should be the key component. We need to remove water. See, our basic aim is to separate acetone from water. Okay, so what becomes our key component? You do one thing. I know in 1K, do both the simulations. Let's see what happens. Give water in one case and give acetone in one case and tell me what is the result. So what results? Okay. So what errors did you get? Can you interpret those errors? What does it say? Then change the upper bound. Okay, Harshit says no phase split occurs. Can it's actually a valid point. It when you do a proper simulation, you will observe that there is no split. Even Akshay also pointed out. Okay, fine. So there is no phase split. What does it mean? Can you interpret it? There is no phase split. Why aren't we getting any phase split when you use decanter? Why this operation can't happen? Uh, don't give the flukes. Just think for a minute and then answer. Irrespective of the quantity, there should be separation. Okay. Think according to thermodynamics. Don't give some random answers. Gibbs free energy of mixing is increasing. Then the separation should happen, right? You know, ultimately everyone aims to have minimum Gibbs free energy. If your mixing is causing your free energy to increase, then you should get separation. Here we are not getting separation. Why? Then it is decreasing. Do one thing, do a calculation in Aspen itself. The Gibbs free energy calculation, then see. You're just guessing either A or B. Think over it. Why don't you get separation in this case? Aspen will give you hundreds of results, okay, but you need to interpret every result that Aspen gives you. Unless you're used to interpretation, then it becomes difficult for you to understand. No answer? No one want to try? What could be the reason? Okay, now let's do one thing. Change the property method to NRTL. Okay, for the same section. Don't put these components for the two itself, the mixer and the decanter. Change the property method to NRTL and tell me what is happening. Why do you want to do a binary analysis for what? No, don't do. See, this for the same flow sheet which you have created, which has a mixer and which has a decanter. Instead of using ideal equation of state, now use NRTL, and then see whether the results which you obtain still remain same. And just put a comment. What result did you observe in this case? Now getting separated. Okay, thanks Harshit. Others, what do you observe? Results available without errors. Great, thanks Akshay. Now can you tell me? Now can you tell me why you are able to separate when you are using NRTL equation and not when the separation isn't occurring when you are using ideal equation of state? Just try interpreting this result. When you are using ideal equation of state, you don't have separation. However, when you are using NRTL equation of state, NRTL method, you are able to have the separation. So how do you interpret this result? Can someone just respond? What do you think? What's your opinion? Because it's a liquid, so what? It's a liquid, fine. I'm using gaseous equation of state for liquid. Yeah, we are doing the separation here, right? We are separating two liquids. So equation of state should be valid. Mm, may not be the right explanation, but I can tell you that you are on track. Just think some more. When you were using ideal equation of state, you didn't get any result. However, when you are using NRTL, you could get the separation. What could be the reason? Great. Thanks, Harshit. That's a wonderful answer. So Harshit says that ideal the interaction between them is zero, and in an NRTL polarity helps in separation. That's a good answer. There is one more reason as well. Can others point out? This is accepted answer. Okay. Others, Akshay, can you think what could be the reason? This is a valid answer, Harshit. This is an accepted answer. So essentially, he is telling that when you take an ideal gas equation of state, ideal gas equation of state for every component, we assume that there's no interaction between molecules. However, when you are talking of some precipitation or separation, there must be some phase split, right? So unless you have this phase split, unless you have this molecular interaction, there is no phase split. Okay, so ideal gas doesn't consider this interactions, so it says interactions among molecules is zero. Okay, so that's one of the explanation where in this case you could see that you had separation to be zero when you are using ideal gas equation of state. However, with respect to NRTL, you are able to get separation. Thanks, that's great. Good, Harshit. Okay, let's continue further. Okay, now take a separate stream of MIBK. Okay, let me just post. This is one I have done, right? Okay, so add another stream. This has a flow rate of 50 LP per hour. Put it to the mixture and then a decanter. Can you do the rest of the process? just put a message once you have completed the simulation. Okay.
Second MIBK feed is pure MIBK.
Yes, it's pure. It's pure MIBK at the same conditions with the flow rate of 50 LP per hour. So can you just tell me your status? Where are you? Okay, great. Thanks, Harshit. We'll wait for others. Okay, great. Thanks, Arun. What about Akshay? Akshay, please let us know once you are done, okay? Others, please wait for Akshay. Let him also complete. Oh, okay, your simulation got deleted. Okay, fine. We'll just add some more things to this flow sheet. Okay, you just carry on. So now, what I want you to do. Can you just tell me what fraction of acetone you are able to recover from the initial acetone water thing? Just put a message. What fraction of acetone you are able to recover? Okay, 20. Okay, now for this setup, can you add a red frac here? The outlet, whichever you are taking, just add red frac, which has got two products. One taking out from the top and one from the bottom. Okay. So to the mixture of this is stream is acetone plus MIBK stream which is coming out. Send it to the rad frac. I'll just tell you the specifications of rad frac. Okay, just give me a minute. I want you to connect it and then I'll give you the specs of column. So these are the specifications of the column. Okay, so use a 12 tray with the inlet at 6th tray. Choose reflex ratio to be 1.3 and the distillate to feed ratio as 0.9 and condenser pressure as 25 psi. Okay. And once after doing that, can you report these questions, answers for these questions? Do you need any other information with respect to distillation or is it fully provided? What do you think? Is sufficient information given? Which one do you think? Is it a partial condenser or a total condenser? See, in case if you're having doubt, try both of them. Okay? And let's see what happens. Any other information other than condenser? Are you able to do the distillation simulation, everyone? Okay, carry on. Akshay, in case if you are unable to complete, na, take this question, okay? Do it as an home assignment. Maybe I can start the same next week. Maybe couple of minutes, maybe just for 5 minutes, I can just discuss this. So in case if you Akshay, if you are unable to complete it, just take a screenshot of it, or else I will be sharing anyways this slide, so you can download it from internet as well. Okay. Great. Good, Aaron. Yeah, I don't want to discuss answer in today's class, okay? Since if all of you have finished the thing, I can do it. Anyways, I'll come up with direct solution next week. I actually planned for other flow sheet as well today, ammonia production, but we'll get started with that coming week. So the coming session will be your final session, okay? So we'll discuss some more things, some flow sheetings, etc. in the coming week, okay? So, shall we hold this lecture today here and come back next week? Okay, that's great. Then see you next week. That will be our final class. Okay, then. Yes, I know we'll actually discuss more on design spec and optimization. One flow sheet. So in that flow sheet itself, we'll try doing a design spec and optimization. Okay. So that's how it will be the coming week session. Okay then. See you. Professor's mail ID, it's there in the IIT Guwahati website. Just go and check. Okay. That's out of my jurisdiction. Okay, I can't talk about continuing education at this point of time. Even during last semester when we were running this course, there was a similar request. Um, I don't know how to proceed it further. Okay, I'll come back next week. Let me think over it. Okay, then see you next week. Bye. Mm, I'll share it in the coming week. Okay, the final week. I'll discuss once I switch off the recording in the coming week session. I'll share a few things. Okay, fine. Chalo, bye.